Hi guys, hello everyone. Um, it is very similar to the JEE advanced question, but it's not previous year question. Very similar to that. What is the change from previous question to this one is previous question we have seen a similar type of question we have seen JEE advanced. I told already 1993 for 3 marks they have given one thing, and the second question they have given. We have seen in previous video, just previous video, that is advanced 2020 also they have given. In these two questions, in 1993 as well as 2020 advanced, the question was asked about one is in concentration of, in one question they have asked about concentration of H plus, and in another question they have asked about uh, pH of the solution. Okay. In one case concentration of H plus, the another case pH by the giving the data. But in this case, what they have asked is it's they have given the concentration of H plus in terms of pH, and they were asking to find out the concentration of sulfide ion. Okay, yes. Now let's go through here. Right. Let's see the question. Calculate the sulfide ion concentration in zero point 0.1 molar saturated HCl solution in water at 25 degrees when the pH of the solution is 11. Okay, yeah. Here sulfide ion concentration in zero point 0.1 molar saturated H2S. Previously what they have given, metal sulfides and metal bromides, zinc sulfide and metal bromide they have given. But here what they are asking simply the sulfide ion concentration. It's nothing but what? It's very similar to like metal ion only. We can say that. Okay. Keep that in mind, all of you. You have to remember that. Okay. Let's go through now. Yeah. Let us go through the solution of the question here. The first thing what we require to find out is we have already gone through, just go and check the previous video. You can see the total equilibrium constant is equal to K1 into K2. Okay, you can write it as what? Concentration of H plus square into S minus 2 by H2S. Okay, yeah, from where we got this equation? We know that very well. When H2S is dissociated, then because it's a dibasic acid, H2S is which acid? It's a dibasic. That's why here it has two equilibrium constants. That's why you have to keep that in mind. It has dibasic acid, H2S is, okay. Since it is a dibasic acid, it has two equilibrium constants K1 and K2. Okay, alright. What we require to find out is what is the sulfide ion concentration they were asking, right? In order to do that, see, first thing what we require to know, we know that H2S given 0.1 molar. The 0.1 molar saturated H2S solution they have given already. Okay, you can observe that. And what we need to find out here, the sulfide ion concentration, it's very simple. But the concentration of H plus how much? pH is given instead of what? Concentration directly. Therefore, pH is equal to, we know that very well. pH equal to what we know? Minus log H plus. The concentration of minus log H plus, we know that very well. And you know, here it can be written as what? pH is given how much? pH is given as 11, that equal to minus log H plus. You can see here, right? Now, you know, log H plus equal to minus 11. We can write one more step here. Log H plus equal to minus 11, and you know base 10 anyway it is there for log. You can see that. Is that right? Therefore, here it can be written as what? Concentration of H plus is equal to 10 power minus 11. The concentration of H plus, how much you got it here? 10 power minus 11 you got it. Is that clear? Right. Now take this value and substitute in the above equation. take this value and substitute in the above equation. You can write it here. I am writing that, you see, K1 into K2, K1 into K2, 5.7 into K1 is given here, 5.7 into 10 power minus 8, you see that, into K2 is given what, 1.2 into 10 power minus 15, 1.2 into 10 power minus 15, that is equal to concentration of H plus, take that and substitute here, 10 power minus 11, and S minus 2 we required to find out. Concentration of H2S is given already, that is 0.1. Concentration of H2S is given already, that is 0.1. We can say that. Okay, right. Therefore, okay, you can see that 0.1. We can write it. Clear? Is that clear? All right. Now you can see here S minus 2 concentration is just modify this equation. 5.7 into 1.2, that is 6.84 into 10 power minus 23, that equal to 10 power minus 22 um, into S minus 2. This 0.1 term take this side, right side of the equation, then it becomes into 0.1. 0.1 means what here? 10 power minus 1. Therefore, 6.84 into 10 power minus 24. Why? Because 10 power minus 1 into 10 power minus 23, 10 power minus 24, equal to, it is divided by 10 power minus 22, that equal to sulfide concentration. You can write like this. Okay, right. You can write it as sulfide ion concentration can be reported as, 6.84 into 10 power minus 22. If it goes numerator, then it becomes plus 22. It will be minus 2. This is the overall answer what we required to find out. Okay, right. Okay, let us see the next question, because the 13th question, it's very similar to this, but based on again H2S only, we will go through that next question. Okay, let us see now. Okay. See here, actually what we can write here, concentration of Hs minus we required to find out. Yes, I am going to substitute here Hs minus E by H2S. Okay. Yeah. Now, actually for this, in order to find out this, we have to take one more step. The important one we have to consider here. Up to what extent the dissociation takes place, we have to consider. Okay. For that, let us take here up to what extent H2S can be dissociated, we have to consider. Okay. Let us see now how the dissociation takes place. Okay. Right. Now, take here H2S, right? Again, I am going to write the equation. H2S gives H plus Hs minus, right? Okay, now here, let us take here at time t equal to 0, how much concentration? 0.1 mole, and it is 0. You can say that. Before dissociation, at time t equal to 0 means initial, we call it as. Okay, yeah. Next, at equilibrium, what it becomes? At equilibrium, I am going to write here, at equilibrium 0.1 1 minus alpha, you can see here, and 0.1 alpha, 0.1 alpha. Alpha indicates what? Degree of dissociation, we can say that. Okay, what is that? Degree of dissociation. Therefore, you can write the equation, you can take the substitution, you can substitute in this value here. It can be written as 10 power minus 7, and H plus how much here? H plus is equal to 0.1 into alpha, and S minus Hs minus how much? It is also 0.1 into alpha by, you can see here, you can observe very clearly, I am substituting the value of H plus, Hs minus and H2S, because directly we don't know up to what extent it can be dissociated. First we have to find out. Okay, then only we can able to find the alpha value, degree of dissociation, we can see here. Okay, right. Next, what we can write? 0.1 into 1 minus alpha. This is the overall expression, we can write it. H2S is written as what? 0.1 into 1 minus alpha. 0.1, 0.1 cancelled out, and you can rewrite the equation as 0.1 alpha square by 1 minus alpha. Okay, yes. But the point here, what we have to understand is the value of K1 here, it is what? 10 power minus 7. It is comparatively very less. Comparatively very less. 10 power minus 7 means it's very less. Anyway, it's very greater than K2, but here comparatively we know that very well. 10 power minus 7 is obviously it's a less value. Okay, right. In order to, but here the condition is what? The important condition to alpha, to actually we can neglect alpha here. In order to remove that alpha, the important condition is if alpha is less than 5%. Alpha is less than 5%. 5% means what? When we come to know alpha is less than 5%, when the K value is very less, then alpha is less than 5%. That means what we can consider here? Less than 5% means it is equal to 5 by 100. 5 by 100 means what? 0.05. Okay? Yeah. By looking at the equation in this case, the alpha value, because 10 power minus 7 is very less value, alpha how much we will get? Let us see now. But that alpha will be 5 into 10 power minus 2 or 0.05. It will be less than alpha. If alpha is less than 5%, then alpha can be neglected. That point is important to remember. Not only for this problem, in every problem we have to keep that in mind. It's very important point to keep that in mind. If alpha is less than 10%, then alpha can be neglected. Alpha can be neglected in the denominator. In denominator, that means 1 minus alpha becomes 1, approximately 1. On in denominator, see, alpha can be neglected in the denominator. You have to keep that in mind, right? Therefore, if it is less than 5%, then it can be neglected. Not only for this problem, every problem we have to apply that. Keep that in mind, everyone. Okay. Now, let us consider here, right, 10 power minus 7 is equal to 0.1 alpha square by 1 only, because 1 minus alpha becomes what here? 1. We know that very well. Therefore, you just rewrite this equation. Once you rewrite that equation, you see here alpha square is equal to what we can write? You can write it as 10 power minus 7 by 0.1, that equal to 10 power minus 6. Shall we write like that? 10 power minus 6. Therefore, the alpha value here, it is 10 power minus 3. Alpha square, because we have to take the root. Alpha equal to root over 10 power minus 6, or that equal to 10 power minus 6 whole by 1 by 2, 3. Therefore, alpha equal to 10 power minus 3. Got it? But the question is about what? The question is about calculate the pH, the minimum pH we required here to find out. Okay, right. In order to find out that what concentration of H plus is required, in order to find out concentration of H plus, what we have to consider here? H plus equal to what? 0.1 into alpha, the concentration of H plus. Therefore, concentration of H plus is equal to, I am going to write here. Let us see that. Yeah. Now, concentration of H plus is equal to 0.1 alpha is given already here. Therefore, you just substitute the value. 0.1 into alpha value how much? 10 power minus 3. Therefore, it can be written as 10 power minus 4. Therefore, pH is how much then? pH equal to, we know that very well, minus log H plus. Therefore, minus log 10 power minus 4 is equal to plus 4. pH is equal to plus 4. Okay. Yeah. What is the minimum pH required here? The pH here of 0.1 molar H2S solution is pH equal to 4. This is the final answer. Keep that in mind. Okay. Thank you. Thank you so much. Please, it may be helpful to others also. Share this video. It will be, because exams are going on now. Exams are coming towards, mains, second session is there, and advanced also is there. Please keep that in mind and prepare well. Okay, all of you go through these videos. All the very best. Thank you so much.